Hey guys, good evening. Welcome back to my channel. Today I'm going to explore the second part of monotonous stacking. So I felt that it was pretty difficult yesterday when I was trying to solve a question. So I tried another question today. Um, this question, compared to yesterday, it's a easy level difficulty compared to the medium level. But it is, I personally felt like it is comparable to a medium level difficulty, although I haven't solved many questions before. So yeah, I don't know what you guys think, but I'll just dive right into the question. Let me share my screen. Uh, yes, so the question, as you can see, uh, given there are two lists of arrays, um, first list is the subset of the second list. We have to find an output where for each of the elements of the subset, the next greater element from the nums2 list, we have to return them. So for instance, if the element in the first subset is 4, then in the nums2 we can see that there's no um, next greater element because it ends at 2 and 2 is smaller than 4. So in this case, we return -1. This is an edge case. Let's go to another next element, which is 1. If we check the nums2, we can see that after 1, 3 is already bigger than 1. So that means that we have to return 3 for the output. And you can see that 3 is an output. Same goes for 2. If you check 2, 2 is the dead end of the list of the num2. So that means that it also has to return -1. So as you can see, we have returned the output of -1, 3, and -1. So how are we going to approach this? There are ways to do this with the brute force approach, which we check the elements and then we check for all the elements in the nums2 list, whether they have an element that is bigger than the element of the list 1. But in this case, the time complexity will exceed than what is foreseen, so it is not an efficient solution. And I believe that most of the interviews from the companies would have some kind of method to stop this approach. So, like the topic of today, we're going to use the monotonous stacking approach. So we're going to make use of the stack and also a hash map. So a hash map is used to store the results of the monotonous stacking in order to compare them and produce an output. What are we going to compare? We're going to compare um, the the uh, the result of comparison between the element in nums2 and nums1 with the original nums1. So it'll be like the key is the element of nums1, and then the value would be the output. So that's how we map the result into output. So when we iterate over the nums2 array from the start to right, we push every element into the empty stack. And then if when we push every element into the stack, if it is less than the previous element in the stack, then no entry is made. Um, yeah, this is because uh, the element of the nums2 encountered are coming in the descending order, which complies with the monotonous decreasing stacking. What if we encounter an element that is bigger than the top of the stack? That means that we continue popping all the elements that it is bigger than, which are already in the stack. So that's how we do it. I'll actually show you guys an example of how I would do it. So please, let's say that nums1 um, is 3, 4, 1, 2, and then nums2 is 1, 2, 3, 4, 5. So nums1 is a subset of num2, right? So now um, we we start iterating over nums2. So we have this empty stack, and then we push the first element, which is 1. The stack is empty, so we push 1. And then when the element is 2, the top 1 is less than 2, right? So according to our approach, we pop 1 from the stack, we remove it, and then we add the hash map, uh, which will be 1. I think 1 is 2, right? Because we try to push 2 into the stack, and 2 is bigger than 1, so we add this to the dictionary, and now we have just 2, and this one is gone. And then we try 3 again, and then when we try to push 3 into the stack, 3 is bigger than 2, so this also gets removed, popped out of the stack. And then we add another entry to our hash map, which would be 2, 2 is 3. So we keep on adding this hash map, and at the end, we compare it to nums1 subset, and we can see that for 1, um, it's 2, right? So that will be, in that case, 2 in that position, right? Because we have to return an array that has the same number of elements as nums1 list. So we do all the same for other elements as well. In the case that it is not in our hash map, it means that it's -1, right? That's for the edge case. So I hope the explanation was clear. And now we're going to try solving it in the code. So, like we always do, stack, initialize the stack. And then we also have to initialize empty hash map, right? So that would be great map thing, I guess. Great mapping. Empty dictionary. Now we iterate through the nums2, so that would be for num in nums2. And then if the current number is greater than last number in the stack, so top of the stack, we pop the element from the stack, and then we put it in our hash map. So while stack I guess this is like a template. It was also similar for yesterday's one. So if there's a stack is not empty. So I was going to cough. And stack -1 because we are popping from the top is less than number. If it's less than what we want to push in, then we're going to pop the element, top of the element from the stack. That would be great. Mapping stack stack dot close number. So, yeah, so this becomes a key and this becomes a value, right? The number. Yeah, so in that case, we make the dictionary, uh, or else, and then we append the number. No, not else. After this, we just push the element into the stack. And then now we go through each number in the first list and then get the next greater element from the dictionary that we have. So that will be return. Uh, we can use the list comprehension here, right? So that would be create map thing get number -1 for number in -1. Right? Let's check. Yeah. So as you can see, um, the list comprehension that we did was if a number does not have a next greater number in the second list, then uh, we return -1. So that's why we put -1 here. So yeah, although logic was pretty difficult, after we found out how to do it, we solved it. I think this kind of question, if you haven't solved it before, it will be really, really difficult to just come up with it during the interview. So it's nice that I've done it now and hope you guys have learned something from it as well, like me. And yeah, thank you all for listening, and I hope to see you guys tomorrow for the trees. Yeah, it should be trees. Anyways, see you guys.